Hi everybody, this is Dr. Waite. Just wanted to give you some announcements before we start this class lecture number 5. This is the recorded video that's meant to be watched for Wednesday, the 30th of August. As an announcement, remember that this class and also Friday's class online, the whole week is recorded videos. We're not meeting face-to-face in our normal Corbally Hall location. Then the other thing is that you should begin working on homework number 2 if you haven't already. That's due on Wednesday, September 6th, no later than 12 p.m. is when it needs to be uploaded to Blackboard. So before class on Wednesday. Now in today's video, what we're going to be talking about is the concept of economic equivalence. And so it's how different amounts of money can be economically equivalent if they are separated by some period of time. So it's taking into account interest rates and the time value of money. So to do that, I'm going to be introducing two different methods of problem solving. One is called the table lookup method, and the other is the equation method. And so the in-class exercise gives you a chance to get a first taste for both of those methods. Now, speaking of the in-class exercise, I just want to give you a heads up that the majority of this recording was put together in a previous semester, and in that previous semester I was introducing these concepts in the 7th lecture rather than in the 5th, so don't be thrown off in the video when you see at the top of the paper it says in-class exercise 7. I just am always tinkering with what comes when and how to best deliver these concepts, and so you have the in-class exercise posted on Blackboard, and I'll be going through the solution in the video. And if you have any questions, please feel free to reach out, send me a message, and I'll do my best to help you.
There is this table of formulas in your book, and each of these equations can be used to solve for a different unknown. So for example, if you want to find f given p, then you'd use this first formula, which you've seen before on several occasions. And so the way that these formulas are presented is f divided by p is equal to 1 plus I to the n. And so therefore, if you want to know f, you'd take p and multiply it by the formula that's provided on the right-hand side of this table. And so, for example, if you want to find the value of an annual series given a single lump sum future amount, here's the formula for that. To find f given a, find p given a. So all the equations are there, including something we haven't yet talked about, gradients, g. Everything else you've seen already, the p, f, a, but we'll be going over what a gradient is in the coming classes, and you can see the formulas get a little bit complicated when it comes to a gradient. But I wanted to draw your attention to this table of equations. I'll post it on Blackboard, but it's also available in your textbook, and I think it's there in the notes if you've printed those out. So this is the equation method. On a homework assignment or a test, if I say to solve something using the equation method, what I mean is use these formulas. So if I said, find the future value using the equation method, then you would be, in the problem statement, have given an interest rate, the number of compounding periods, you'd be given the present value, and so you'd substitute all those things into the formula. Sometimes you may need to solve for n, the number of periods, or it might be a problem where you have to solve for I. So it's not always just that you're solving for what's in the numerator of this ratio. Oftentimes it is, but occasionally you'll be solving for some other parameter. And so, if you've been through Engineering 111 or Mechanical Engineering 111, you've got some practice solving formulas in your calculator. Hopefully everybody knows the trial and error iteration approach, where you can just solve for I using a variety of different, substitute in a value for the interest rate, and if it's too high or too low, you can make a correction. You keep iterating until you find the value of I that satisfies the formula. So this is the formula method, or the equation method. There's also the what are called table lookup factors. And I've told you about these before, but let's look at one in a little more detail. you can see that in this table lookup factor, it says 8%. And in the back of your book, there are lots of different tables for a variety of interest rates. There's one for 0.25%, for 0.5%, for 0.75, 1, 2, 3, 4. But there isn't a table for like 5.75% interest. So if you have a problem and the interest rate is 5.75, you're not going to be able to find a table that is solved for that percentage. So you'd need to use the equation method if it's some odd interest rate. But if it's a relatively common interest rate, like in the middle or right at a numerical breakpoint like 4 or 5 or 6%, you are likely to find an interest table. And so what each one of these columns represents is for a certain I and a certain number of compounding periods, what is the ratio of F to P? And so just using 1 year as an example, the simplest example we can think of, what would be if you put $1 into a bank account? So P is $1. What is F? It would be $1.08 if it compounds for a single year at 8%. And so N, 1.08, that's the ratio of F to P. And so what if you had deposited $2? Well, the way that we use this is we say F is $2 times 1.08. If this was a problem where N is 1 and I is 8%. So that's how these factor tables can be used. And so if you want to know 5 years of compounding, the future value is 1.4693 times the present value if it compounds for the number of periods associated with the row. So this takes into account compound interest. One thing you'll notice, though, is that there's only 1, 2, 3, 4, 5 digits in this column, and other columns only have 4 digits, 1, 2, 3, 4. Significant figures is an issue when you're using these tables. And so when you're doing a table lookup type problem, in your calculator, keep all of the precision until the very end, and then round off according to how many significant figures there are. And so, if you're working the millions of dollars, it would just be 4 significant figures if you were finding P given F. So you wouldn't be able to report your answer to the nearest penny, in other words. You can, for these equation factors, you can always keep as much precision as you need and report even millions of dollars to the nearest penny using the equation table. But we'll get some practice with appropriate rounding when it comes to these table lookup factors. And so each column is the ratio of the numerator to the denominator is equal to this number when you have the given interest rate and the number of compounding periods for the row that you're on. So any questions so far about these tables and how we use them? All right, so just as an illustration, you put $5,000 into an account that pays 8% per year, then the amount after 10 years is closest to, so this is the graphical representation of the problem. And once you get acquainted to reading cash flow diagrams, they're just so much more compact and efficient than the English language depiction of what's happening. Like you can just look at it and see, find F given P. I mean, it's just all right there, 10 years. So what we would do is P is 5,000. We want to look up the factor for N equals 10 at 8%, and we're finding F. So find F given P for 10 years, 2.1589. So our present amount was 5,000. So if we multiply 5,000 by the factor 2.1589, we'll get 10,794.5. And so the answer is 10,795. We need to round off because we've got 5 significant figures, and we can't report it to the nearest penny because of that round off. So the answer is C. So it's just an illustration of how we would use the lookup factors. Okay, what if we are, let's see, we are going to find the present value given a future amount. So we know that in 5 years we want to have 50,000 available, so how much should we put into the bank now? So this is find P given F. So this is a 10% table lookup. So if we went and found that lookup factor in the back of the book, we would see on the 10% table for n equals 5, the factor is 0.6209. So you simply multiply the future amount that you know by this discounting factor, and then that would give you the amount that you need to calculate. Now let's go back to the table, and I want to point out one thing. The greater the number of years, look how find F given P is increasing. That's the effect of compounding, where the amount gets larger and larger the more years that you're compounding. But if you have a future value and you're trying to find the present equivalent, the ratio keeps getting smaller and smaller and smaller. Now think about why that is. What it's saying is that a certain amount in the future has less value today the more years in the future it is. And so that's why it should make sense to us instinctively that the ratio of P/F is declining over time, because what we're looking at for 10, that's a certain amount of money 10 periods in the future. For 12, that's 12 periods in the future. And so the further out in the future you put that amount, the less value it has today. And that's why this ratio keeps getting lower and lower. The number of compounding periods increases. So back to this example, we're trying to find the present equivalent of 50,000 in the future when we're discounting the amount by 10% per year. So I've used the verb compounding in previous examples. Compounding means moving money to the future. In this case, we're discounting. Discounting means you're moving money from the future to the past, or further back in time, perhaps even as far as the present. So this 50,000 is in 5 years, and we want to discount it to find out what's the present equivalent. And the word discount just kind of implies that it's going to be less as you move money back in time. So if we look up the factor, you'd find the 0.6209. So that gives you 31,045. And I guess if we were going to look here, it's answer B, because answer B has rounded off to the nearest 4 digits, 1, 2, 3, 4. So we don't actually know that it's 31,045. That would round up to $31,050. All right, so let's look at the in-class exercise for today. We've got plenty of time. How many of you have in-class exercise 7 printed out? Most people have it printed out. Good. Do you have 3 problems and then also the table lookup factor and the equation? All right. I change these in-class exercise from semester to semester, and I want to make sure that I've got the same one pulled up that you've got printed, and I think that it is. All right, so let's look at this first one. Let's talk through it together, make sure we're on the same page, and then I'll turn you loose to start your problem solving, collaborate with your classmates. Of course, I'll be circulating around with the answer. So you've got a statement that I think the first thing you ought to do is draw the cash flow diagram, just to summarize what it looks like visually. And we want to find the present value of a future amount that's specified. And so here in the parentheses, we're going to get practice summarizing the type of problem it is. Remember, in the numerator is the one you're finding. The denominator is what's given. So that's That's our typical approach, like our convention. Numerator is unknown, denominator is known. Of course, I equals question mark. That should be obvious. And n equals question mark also. We can tease that out from the details that's given. But then I'm saying go over to the third page and find the formula that we need to use to solve that problem. And so it's from this group of equations that I want you to identify which one applies for the first problem, and then use that to calculate the factor you're going to need. So use the formula to calculate the factor, and then find out the amount according to the equation method, so the exact to the penny amount of the present value. And then finally, the 8% table is down below. So find the same answer using the equation method and also the table lookup method, and we'll see the subtle difference in the answer because of round off. Okay, let's look at the first problem. So first things first, the cash flow diagram. I noticed some people had the arrow going down at time 0. And we've had several problems in the past where I was asking you something like, how much do you need to put into the bank today to be able to withdraw some amount in the future? So I can see why you'd be in the habit of having the amount at time 0 being a downward arrow. But look more carefully at what this is saying. It's saying, what is the present value of the future payment? So in other words, it's saying, you get $50,000 7 years from now. What's the present equivalent of that $50,000? And so the present equivalent of that amount is going to be still an inflow to you. And so that arrow should be up at time 0. And so P equals unknown. We don't know the quantity yet, but you can either get 50,000 in 7 years or how much today is essentially what we're solving for in this problem. Okay. Now, summarize the problem in this form. And so the way that we're going to summarize this inside the parentheses, it's find P given F. So P is in the numerator, F is in the denominator because F is given as 50,000 and P is the unknown. So that's the first term in the parentheses. And then we say I equals 8% just to classify what interest rate applies here, and then the number of periods. So it's 7 periods that this amount will be discounted to time 0. All right. Choosing from the list provided, write the formula that should be used. And so the list provided is this list. And so the formula for P/F is 1 plus I to the minus n power. So that's the inverse of the formula that's above it if you were going to find F/P. But we're finding P/F. And so here's the formula that applies. 1 plus I to the negative n power. And then part C says use this formula to calculate the factor. And by the factor, what I mean is just what's the decimal ratio of P to F. So if you substitute in the n equals 7 and you substitute in I is 0.08, then what we get is 0.58349. Now here's something I want to draw your attention to. You see like I've got the ... after this? That's just going to be my shorthand but there's a lot more digits that continue, and I kept that in my calculator, but I don't want to just write them all on the paper. You know, like there's 16 or 36 or however many digits of precision your calculator keeps. So it's not exactly 0.58349. It's 0.58349 and a bunch of other stuff, and I didn't round off. I kept it in my calculator so that when I multiplied that by 50,000, it was accurate to the nearest penny. So you should do the same thing. When you're calculating using this equation method, I mean, it seems obvious you wouldn't just say 0.58, right? That would be rounding off too much. And it wouldn't be right to do 0.583. But there's no reason to round off until the very end of the problem. and then you can report it to the nearest penny. So that's what those little dots means. And so when I multiply that by the 50,000, if we're being accurate to the nearest penny, it should be 29,174 and 52 cents. So did everybody else also get that same amount? Thumbs up, nodded heads, good. Now, if we go over here to the lookup factor, when we calculated ourselves, it was 0.58349. What does the lookup factor say? So here's the 8% table, P/F, and 7 years. It only says 0.5835. So it's not going to be as accurate, and we're going to have to round off at the end when we use the lookup factor. Okay, so if you do the table lookup, the ratio of P to F is this value. So that means if you're solving for P, you just multiply F by this. Coincidentally, if you were solving for F, all you'd need to do is divide P by this factor. And you could use it to solve for F if that's what was the unknown. But in this case, it's 50,000 is the given in the future amount, so 29,180. All right. So that's the first problem. The second two problems you ought to work on, let me just bring them up on the screen so that this is included in the lecture video. And I know some of you have already gotten started. That's great. If you've already got an answer, let me know. I'll be wandering around to address questions and look at what you've got. All right, so the solution to the second problem, if you do the lookup factor 2.5771, and that comes from, well, that looks really crummy there, the P/A column, 2.5771. So you multiply that by the value of the annual series, and then you can calculate the present, and you have to round off to the nearest dollar because there's only 1, 2, 3, 4, 5 significant figures on that one. And then for the third problem, we're using the equation method. So you substitute in 0.115 for I and 3 for N, and that ends up being 3,095 and 82 cents, and you don't round off because we have all this precision from the equation method, so it's accurate to the nearest penny.